that is complete adherence to the phrase sun-kissed hair if I've ever seen it. That is really quite interesting. Now, I did just finish and upload the DeepSeek open source day 2 video. However, Alibaba and kind of like Quen associates, if you will, unscientifically stated, but they dropped something called Wan2.1 Video 1, or it's called Wan2.1 right here. And this is essentially a state-of-the-art video generation model. So this is a T2V model, which stands for text to video. And the really cool thing about this is the actual, relatively speaking, for these types of models, low amount of video RAM that it actually needs to generate video. So as we can see right here in the GitHub repository, which was just uploaded like 20 minutes ago, which is pretty cool. And I wanted to just test this ASAP because I love the video models. They are perhaps very funny depending on what you do with them. But this only requires 8.19 gigabytes of video RAM for the tiniest model, which is a 1.3 billion parameter variant of Wan, or Wan, probably Wan, I think it's the correct terminology and pronunciation. We can see that on a beefy GPU like a 4090, it could generate a 5-second 480p video in about 4 minutes without optimization techniques like quantization. Its performance is comparable to some closed source model. So this is a seemingly pretty performant and high-end text-to-video model. And being that this is really cool and exciting, I want to just go ahead and try this really right now. I should also note that I don't want to just kind of skip over some of the other parts of this README, where basically it actually talks about some other tasks that Wan is capable of doing, such as text-to-video, of course, which is what we're interested in, well, me personally, image-to-video, which is also very cool and will be fun to test, video editing, I'm not sure what that would mean in this scope, text to image and video to audio, enhancing the field of video generation or advancing it. So just wanted to kind of get that out there. To begin with the installation, we're just going to start from the quick start section right here. And fortunately, this does actually look pretty simple. So we initially began by just cloning this repository and then changing our directory into this repository, which we can do by simply copy pasting those 2 commands into the terminal. And once that is done, we will see that we are now into our cloned repository and can then go ahead and proceed with the installation of the dependencies. Now, it does not specifically mention here making a conda environment or something like that. However, personally, I always do like to do that just to keep things isolated and containerized so dependencies can't actually cause problems with one another. So basically, I just want to take a peek at this. I think Python 3.10 should work fine. So I am basically going to just create a conda environment real quick for this. And once I am in my conda environment, we will go ahead and, I think they changed the name. That would make a little sense if they did omit the X from the end of that. But so once we are in the conda environment, we are just going to then go ahead and run the pip install-r requirements.txt. And based on what is listed in that file, the torch version is correct to what that is. Now, I mean, I could go ahead, I'm not even gonna waste the time because this laptop won't handle it. It is partially frustrating that it's like, oh, it's so close to 8 gigabytes, but it requires 8.19 gigabytes of video RAM. So unfortunately, if you have an 8 gig card, probably not going to work. So this was just to kind of show how you actually go ahead and get this set up. However, once this is done, the next step will be to actually go and download the model weights, which you can see they are linked right here in Hugging Face. And they do actually just have a simple command right here to download the model weights using the Hugging Face CLI. And if you have not installed that or run it in your system before, we will just actually show how to do that because it is rather simple and it makes it easier than having to go and manually like pull the weights and then put them in a folder and things of that sort. So once the requirements have completed installing, we will just go ahead and install Hugging Face CLI as referenced right here to actually download the model. And then the way I downloaded the weights as I was doing the 1.3 billion parameter model, I went to the Hugging Face page for that specific model. And if I recall correctly, there was a specific download script for that model, which is right here. We can see this is the 1.3 billion parameter model. And basically all we're going to do now is just actually go ahead and run this script, assuming we did install the Hugging Face command line. And when we do this, it will go ahead and download a few files. Some of these are a bit large, some of them not so much, but overall, I think the total download size here, at least for just the model itself, is quickly looking at this, and there may be some other things that I missed, but probably around a 16 to 18 gigabyte download. So it may take a little bit of time depending. However, I have actually already downloaded all of those relevant model files on the computer behind me, which is what we're actually going to use to do the testing here, since this laptop is not adequate in size. So I am actually going to stay on this laptop. I apologize if there was some confusion there. I'm just remotely connected to the computer behind me. So when you see NVTop right up here, which is just a way to monitor the graphics cards and their utilization, this is referencing the big desktop behind me. This laptop is just basically acting as a remote terminal right now. With that, basically once we actually have installed all of the required dependencies, set up our environment to actually run this, cloned the GitHub, and then have all the models on our machine, we can then go ahead and basically, once we're in the directory, so basically if you are within this folder, you will see that there is a generate Python script right here. And that is how we can go ahead and actually try our first generation. So I'm going to just test this before I deal with trying the web interface or anything like that, because I just think it would be quicker, and that way we can work out whether or not everything's set up correctly or not. So we do want to make sure that we actually get the correct prompt to run this. And what I mean by that is if we go down here into the GitHub repository where it gives us the sample for the single GPU inference, it is defaulting to the 14 billion parameter model. So we want to make sure that we are going to be using the 1.3 billion parameter model instead, which is the second one right here. So just make sure that you don't accidentally try to run this one if you have the 1.3 billion model, because it won't work. So we're just going to copy this right now, and then assuming we are in that directory, it should hopefully go ahead and actually generate this. Now, I am not 100% sure how long this will take, but hopefully we'll see some GPU utilization, and then once it's done, we'll actually be able to take a look at it. And now we can see that it is starting to go. So 1 of 50, and we can see the graphics card utilization is being very heavily utilized at 100% right here, and video RAM right now is showing me 10.219 gigabytes. So I actually do need to keep an eye on this temperature because the fan curve isn't really set up to respond to graphics card spikes. So this will take a little bit of time. We can see here that it gives us an estimation of how long it will take, which currently is around 6.5 minutes. These video models take a while to generate, and that's something you'll likely notice if you've used Sora or VO or something like that, is it's not instant like a response from ChatGPT or Claude or Gemini or something like that. So obviously that's probably pretty understandable based off of what you're actually getting back here, but just something to be aware of, I suppose. Okay, I have the generated video. We can see it was just saved into the cloned GitHub repository directory. So that's where it will save the video, at least when running just the generate script from the command line. So let's just take a look at it and see. That's significantly better than any of the local video models I have tested. However, I will say that I have not tested any of them very recently, so I don't know what's been done since when I last tested, but this is significantly improved just looking at like the actual lighting and the shadows and things like that. Understanding this is a default example, which I always kind of tend to stray, no pun intended, because it's cats boxing now. But I don't necessarily like doing the default examples because you always kind of in the back of your mind assume they're designed to look really good. So now that we see that this successfully at least completes, we are going to just now go ahead and actually run the web interface so we can play with it through a more aesthetically pleasing medium, if you will. So this may be specific to my setup here and the fact that I'm remotely into a different PC and some other things like that, but I was having a problem where every time I tried running the Gradio script, which should realistically just be simply run by going into the Gradio directory and then running one of the sample scripts right here, as we can see for running Gradio interface, which was right here, running local Gradio. The problem was I didn't want to use the prompt extension method, and for some reason it seemed like that was tripping it up. It just kept trying to re-download the files that I already had. So I made sure it was pointing to the right checkpoint directory and everything, but it still wasn't happy. So I just added something into the actual Gradio script to kind of bypass the prompt extension thing, and that seemed to work. I also just manually set it to actually give me a live shareable link, which I only did so that if I click on this public URL right here, we actually are brought to the web page as it would be served on that machine right there if I were in front of that. So basically, this is just using this on the local 3090 Ti right now, and this is our first look at the Gradio web interface. We can see the resolution is correctly set to the model parameters as they kind of say they should be. Everything else here, I think these are also somewhat referenced in the repository. If you are using the 1.3 billion parameter model, we recommend setting the parameter sample guide scale to 6. The sample shift parameter can be adjusted within a range of 8 to 12 depending on the performance. So the sample guide is set to 6, and then the shift can be 8 to 12, and we see it is defaulted to 8. So we do seem all right here. Target language of prompt enhance, I'm just going to leave that because I just am not doing that right now. So we're going to have to manually enter a prompt, and being that prompting is very important here, I am actually probably going to have an AI like ChatGPT enhance the prompt, which is kind of the whole point of them actually giving that as an option here. But for the interest of brevity and just wanting to test the actual video portion of this, I omitted like trying to set that up. So in order to first test this with a good and thorough prompt, I am actually going to use the one that I tested with CogVideoX a while back, which was another local video generation model, because I actually do have a comparison for this from both CogVideo and Sora. So I am initially just going to start with that, as it is very detailed and will give us kind of a good reference point for this compared to CogVideoX, something I've tested, as well as Sora, as I do have both of those. So with that in, and because we are not doing any prompt enhancement, I am basically just going to go ahead and click generate. These settings right here are set to the specific recommendations from the GitHub repository for this specific model. So we will go ahead and just try this. So unfortunately it failed with an out of memory error, and that is upsetting because I had ChatGPT ready to make some interesting prompts to test. So I do recall there was something here in the repository that talked about if you get the out of memory error, then you can basically, I think, offload the T5 to CPU. So I am basically just going to amend the actual command I'm running here to do this, to also have these flags as well. So I'm going to try this once more. I just set offload model to be true in the Gradio script that we're trying to run here. So hopefully that will alleviate the out of memory error, and I will just remove those flags I tried to add there. For some reason the T5 CPU one didn't work, and it seemed a little more intricate to get that integrated with the Gradio script. So we are basically just going to try this once more. I'm going to make sure that I get that prompt again from the CogVideo repository, being that this will allow us to have something to actually test this against, both with Sora and with another open source offline kind of thing like this, which is CogVideo. So hopefully that alleviates the out of memory error. We are just going to paste this in right here. Because we are not doing the prompt enhance, I can pretty much just leave either one of these language selectors as they are, and all of these are set to the recommended values as when we first tried this. So I am just going to click generate video, and then I'm going to kind of stay with it here and watch it, as we want to make sure we don't run out of memory as we did before. This will probably take around 7 minutes to generate. So all right, we can see we are on step 48 out of 50, now 49 out of 50. Fortunately, we did not get the out of memory error. I will just quickly touch upon what I did to avoid that from happening. Again, I don't know why this is utilizing so much more memory. It could perhaps be from the CPU offload flag as well. I'm not 100% sure, so I just wanted to kind of make note. But this did seem to have successfully completed, so hopefully in a second we will see this generated video populate with the prompt. And let's take a look at this. I will, of course, full screen it. Wow, this is, for the 1.3B, this is really quite good. And I say that having tested this exact prompt both with Sora and CogVideoX. I am going to play the generation from those as well, but I mean, obviously, the longer you look at it, the more you can nitpick, but this is really quite good. The movement in the clothing really matches like the movement of the body. I do want to check for some reason. I can't rewind this while it's full screen, so I apologize for that. We may have to just look at it like this for a second, but I want to see if the sand kind of, all right, so not so much, but that would again be kind of like over the top if the sand, but the way the waves crash, the rippling of the waves seems consistent. Obviously the paper plane thing is kind of a more abstract thing to add to this, but it kept the clothing accurate to the prompt as well. Overall, for a local offline model with a small parameter size like this, this very much is definitely competitive and punches above its weight class. This is quite impressive. This is so let's show the other two prompts, videos that I got with this, one from Sora and then one from CogVideoX. So I do want to do one more that is perhaps a bit more entertaining potentially. So I'm just having ChatGPT come up with it because I want it to be something that would be the equivalent of prompt enhanced. All right, so that just generated like a legitimate script. I think this may be the first documented example of malicious compliance from an AI. I got a little mad and called it bozo. And then it basically was just like, okay, screw you. I'm going to regurgitate the original prompt exactly, but just right. Finally, she drives a convertible along the coastal road. All right, BRB. I'm going to concatenate this generation to not show too much because we're only doing 5 seconds or so, but GPT-4o did a more acceptable job here. So I am simply just going to go ahead and place this prompt in there now. We will reduce the size of this so we can just keep an eye on the graphics card utilization. And basically we will go ahead and just generate this, wait about 8 minutes, and then see how it turns out. And I really do think I just angered ChatGPT in that previous little incident we had. So, all right, as this is about to finish up, two things. One, it seems like it's only taking 12 or 13 gigabytes of video RAM now. The first run we did in this web interface, I believe, took 18. So I can't really comment on that right now. I'm sure it's something quite explainable that is just eluding me currently. But we are pretty much done right now. The prompt, once again, is just a striking woman glides along a winding coastal road in a sleek convertible. The wind tussling her sun-kissed hair, she grips the wheel with effortless grace, her beige. Okay, and then it just describes like the clothing. So, and all I'd said to ChatGPT was just describe like an attractive person driving a convertible around a winding road. So let's just go ahead and take a look at what we have here. All right, so someone can implement press spacebar to play in the web interface, please. It's like the Morgan three-wheeler. This is actually really good. It took me a second, but I mean, that is complete adherence to the phrase sun-kissed hair if I've ever seen it. That is really quite interesting. The camera movement did, you know, let me just full screen this so we don't have to keep trying to full screen that. But okay, the car's quite wonky, very wonky. However, the rest of this is really like, it kept the same exact clothing style, which we recycled from the original prompt we tested. The hair definitely worked. The scarf is not really trailing behind like a whisper of freedom, but you can see she's smiling and looking at the camera, and then the camera pans around driving. Really, again, I don't want to sit here and just analyze every single cinematic aspect of this generated clip, but I am going to say, and really we'll close this out, this model is fantastic, and I am not overstating that. I'm not hyping this up. This is fantastic and is definitely very much comparable to a lot of state-of-the-art models that currently exist, whether they be open source or closed source. I'm testing the smallest of these available models. I don't think I even have the capability hardware-wise to test the 14 billion parameter one, but I am very eager to see what folks at home who can test that actually generate, because this is quite good. So that is going to conclude this. I will be back on posting some more DeepSeek things for day 3. I should probably get a couple hours sleep before they drop that, but I wanted to get this out when I saw it because I've loved the video models. They're absolutely hilarious and they're cool. Obviously, there's more like you can do than just laugh from them, but they are fun to play with. And this is really quite cool to be able to actually go ahead and do this locally. So that's going to wrap it up for this morning. And it's past my bedtime, so all right.